This conference will now be recorded.
Okay, so let's start the new tool. We have a few topics in shell scripting pending, which I'll cover in maybe tomorrow or something. So today let's start with the new tools that will be good to get started. Okay, so Abhishek, are you from Kotokas, right? So let's get started. Can you see my screen, all of you?
Yes, yes.
So today I'm going to show you the demo on Docker. That is something which we'll do. There's a new tool, and we need to understand things because this is little new tool, and immediately if you think it'll become a master, no, but little bit of care required, attention required for this tool actually. So that is important. Okay, so here this is my AWS. Hmm. Okay, so the first thing, am I starting recording? Yes. The first thing, what is Docker? I'm going to teach you what is Docker. Then I'm going to teach you why we need Docker. Why Docker? Why Docker? Third thing, I'm going to teach you how Docker works. Fourth thing, I'm going to teach you how to install Docker. Fifth thing I am going to tell you component of Docker. Component of Docker. Sixth thing I'm going to tell you uh, life cycle of container. Then working and accessing containers. Okay, and then working and accessing containers, and then what? Last one, uh, troubleshooting containers. Troubleshooting containers. Okay, and then I'm going to teach you how to create image. Okay, and then how to share with other folks. So this we will talk about in tomorrow's sessions, which is, and today we'll try to cover this one, or let's try to cover this one together today. I think let's have it 2 sessions today, though we have a very low attendance, I think, but let's try to cover today. Okay, so can we get started, all of you?
Sure.
Yeah,
Sure.
yeah. So here, the first thing is what is Docker? What is Docker? So before understanding Docker, you should understand Linux, and I'm sure you must have attended my Linux kernel session. Linux fundamental, you should know Linux. I'll Those who have not got this, please buzz me on the WhatsApp. I'll share the recordings of last session. Linux kernel is important actually for this. You will understand that one. Then you should know VMs, virtual machines, and virtual machines. All of you have worked with it, right? Anyone of who should not work with virtual machines? Anyone? Okay. So these are the Linux kernel VMs. So what is Docker? So guys, when I see Docker, Docker is a container, okay, container management tool, or I should say platform, not a tool. So what is a VM then? What is VM? Uh, what is a VM? What is it? Virtual box. Have you used the virtual box, right? What is this? VirtualBox. So VirtualBox can VM management tool. Okay. So virtual machine management platform. Docker is a container management platform. So here when I say platform or tool, a tool, what is the advantage of using tool? Tell me. What is the advantage? Anup, you can hear me. Abhishek, you can hear me, right?
Yes, yes.
Okay. So what is the advantage of tool? Tell me. What is the advantage of tool? Why we use tool? Nowadays we have so many tools. Every month, every year we are having different tools. Okay. So here tools will save your cost for the work. No? Save your cost, save time. That is very important. And improve quality. Improve quality. So these are the things which will do whenever you say use this tool, that tool, a lot of tools we have. So this will save your time, save your costs, improve your quality of the work. So then you will say, Rajesh, how Docker will save my cost? How Docker will save my time? How Docker will help us to improve quality? So you have to put it in this context. Let's say VMs, I'm just giving you example. If you run a VM, certain applications you want to run, okay, in the VM you run applications, right? So let's say here is taking one CPU, one CPU and 1 GB RAM. VMs. You run application inside the virtual machine. This virtual machines is managed by VirtualBox or VMware or AWS or Azure or Google Cloud, no problem. But let's say it is consuming one CPU and 1 GB RAM. So now when you migrate to container, no, then I'm just giving you this just a way to understand. Okay, 1/5 of the resources of VM. So tell me, is it saving cost or not? So now think about it. In the production server, you will run thousands of VMs for, let's say you are the SRE engineer for Flipkart. So how many VMs a Flipkart is running? Somewhere close to 10,000 VMs minimum. So now 10,000 VMs you are paying for it, but now you are reduced on 1/5 of the VM infrastructure using container. So tell me, is it saving cost or not? All of you, yes or no?
Yes, yes, yes.
Sandhya, Vipin.
Yes, sir. Yes, sir.
So that's why we are learning now. You got to know because why every organization love Docker. Why they want you to learn Docker and implement the fast because saving cost in a data center. Now then you'll ask how it can save time. So let's say if you are creating VMs, you are spending 5 minutes for it. Not you. VMs will be created in approx 5 minutes. Let's say. Do you have any idea how much time it will take to create a container? 1 second. So here you are creating one container in 1 second and 10,000 container in 1 second. Yes. So fast now. Deployment has so fast. You want to deploy the new product? 1 second. You want to upgrade the new product? 1 second. You want to downgrade? 1 second. Life has become so easy now. Okay. And here, when I am saving your time, look at this. So if you want to create infrastructure dev environment, 1 second. You want to create a QA environment, 1 second. You want to create a production environment, 1 second. So here I'm saving lots of time and lots of cost. So where you should focus? You should focus on the quality, code quality and test quality. That means write a good code, write a good test actually. Because you are saving time. Earlier, what we were doing, struggling half of the day for the infrastructure issues. Now you have no problem and then saving cost. So if someone will ask you, hey, why you are learning Docker? Do you have a reason for that or not? Tell me. All of you,
Yes,
do you
yes,
have a
yeah,
reason for
yeah.
it?
Yes, yes, I have.
So that is the why we are learning Docker. Next terminologies what we have in that what is Docker is called management. Management. So guys, here in the virtual box, you had a virtual box, VMware, AWS, Azure, Google Cloud. All what you do, create a virtual machines. So what you do? Typically, you create a virtual machines and you have done it in your laptop or AWS. You might have done it. So you create a VM, start the VM, stop the VM, restart the VM, pause the VM, unpause the VM, and then kill the VM and remove the VM. These are the things you do that or not? Tell me. Sandhya, you do it or not?
Yeah, you do.
Yeah. So something like this here also we'll do that. Management means here create a container, start a container, stop a container, restart a container, pause a container, unpause a container, kill the container, remove the container. So here you understood that this is the management means using Docker, you can create a container, start a container, stop the container, restart the container, pause, unpause, kill and remove. So that is also clear. Now last uh, terminologies what we have is what is a container then? What is container? And this is a very important questions. Now you need to know what is container. And that I will explain it to you in few minutes. Understood all of you? So guys, now if you want to know what is container, in order to understand containers, you need to forget the keyword called container and you need to focus on the one statement and you should try to find out the answers for it. How how application runs. Simple. How application runs. Maybe I will elaborate this question. What are the resources? What are the resources we need to run one applications? So this question, if you try to find out, if you get an answer for this question, you will understand what is container. Very easy way. So now let's say I want to run one applications, any application. I want to run Apache. I want to run PHP. I want to run Python. I want to run MySQL. I want to run Jira. I want to run this. I want to run that. I want to run any application. What are the resources we need? So if I start from scratch, what are the resources we need? So the first thing which we need hardware. Hardware means you can call it CPU, RAM, and storage. How do you get it? How do you get it? You have a laptop or you go to AWS, you get that hardware, virtualized hardware. After that, on top of that, you have an operating system. Correct? No? Operating system. Now, guys, what is operating system contains? Can you please tell me? Operating system contains what it contains? All of you. So this operating system typically we have two kind of file system. One is a boot file system, and then plus we have a root file system. Root file system. So boot file system is equal to what? So boot file system means kernel. Okay, and then root file system means what? Let me show you root file system. So here I'll go to Google and try to find out a root file system and go to the images and click here. Have you seen this kind of file system ever? Have you seen this, all of you?
Yes.
You have seen this, huh? All of you have seen that. Recall that, where you have seen this. Vipin?
Linux server.
Oh, yes. Guys, when you log into Linux, don't you see this kind of file system? Starting with the root, you have a bin, opt, tmp, var. Let me show you Ubuntu at WSL if I go. And you see here ls, see here. This is the root file system. And in the root file system, you have everything. Look at this. It's matching, right? See that? Are you getting Anup?
Yes, sir.
So this is the root file system. But kernel, you cannot see it because kernels is running in the ROM. You might have studied in a very, very first class of your computing. So kernel is running, is a boot file system, you call it, is loaded in the ROM, and root file system loaded in the RAM. Okay, so you see here virtual RAM. So we work on that OPT sometime, or user home. Where is user home? Here it is. This is the one. Var also here some files. So okay, coming back to the question, what are the resources we need? So we need some hardware, and then on top of that we need a kernel, and then root file system. Okay, root file system. So kernel, what is kernel? Let me find out what is kernel. So if I try to find out what is kernel, see here, the kernel is a computer program. It's a program. Okay, mind it. Kernel is a program, and kernel is running entire operating system environment and then loaded the root file system. Okay, so now again come back to the questions. What are the resources we need to run one applications? So when I look at the kernel, okay, kernel we have a few components. Which are the components? Different types of program. Mind it, it's a kernel is a computer program. So they will then you will ask Rajesh what kind of program it has. That program categories must be there, right? It's a program. So kernel we have some of the classifications, in program classification. So one of the code which you call it a namespace. Another one we call it a C groups. Other we call it a capability, capabilities. So these kind of programs you have in the kernel. Okay. So kernel, you have a namespace kind of program, C groups kind of program, and capabilities kind of program. Okay. Further, so let me first show you this program category. So kernel, look at this image. Look at this image. Good image. Very old, but very effective. Why is not coming? Huh. Look at this. When someone asks you what kind of program kernel is having, Linux kernel is having. So Linux kernels is having multiple kind of program. It's just a code which get loaded in ROM when you start your computer, right? So this code get loaded in the ROM. So you have a C groups kind of program, namespace kind of program, capabilities kind of program, and few more kind of program you have. So next question you will ask, okay, what these programs are doing? So basically I will divide the namespace into 4 more sections. What section? So there is one section which is called user namespace, network namespace, bid namespace, MNT namespace. So that means you have a kernel and these are the namespace kind of program, user namespace code, network namespace code, PID namespace code, and an MNT namespace code. So these are the 4 primary code you have it in the kernel, and then C groups and capabilities. So now next question you will ask, okay, I understood kernel is a computer program, nothing great. I knew that from since my college. Okay. And then namespace kind of program, then it is having the code which is of for namespace, then C groups and capability. Again, the namespace is divided into 4 different kind of code, user namespace code, network namespace code, paid, and MNT. That is okay. But what exactly these are doing? Are you understanding, all of you? What exactly these are doing? So you need to know that. Are you understanding, all of you?
Yes, yes.
Okay. So now we need to find out this answer for this. And if you find out the answer for it, you will understand the container. So let me ask you one question to all of you. Now, when you understand the concept of class and object, right? Class and object. Look at this image here. So class and object. What is a class and what is object? Tell me. What is a class and object? So you might have studied this. Oops. So class is just like a code, but what is object? Any idea? What is object? Hmm. Okay, let me
Object is
ask you
instance
another
of class.
instance
Object
of class.
instance of yes, yes.
Yeah. So object is basically running instance of class, right?
Sir.
Right now. So class, do they consume the resources? No. Object, do they consume resources like CPU, RAM, and storage? Yes. How many object you can create from one class? How many objects you can create from class?
Multiple.
Unlimited, correct? So
Yeah.
what is the limitation? So limitation is you can keep creating objects, instantiating objects, as long as you have a hardware in your machine or CPU, RAM, and storage. Agree with me, all of you?
Yes.
Yes, Raj.
Yeah. So now this is the code. You forgot that kernel is a code, computer program. Now these are the code. You run 10 times, you get 10 instance. You run 200 times, you get 200 instances, just like that. So what is a user namespace will do that? This code, what exactly the function of it? So this will create one user. This will create one network. Okay. This will create PID. I mean, let me put it up in this. You can create user, you instantiated X time, it will create N number of users. That means multiple users. Multiple network you can also create. PID tree. What is a PID tree? Let me tell you. Look at my system. I'm showing you the Windows itself. And here you have, look at the
Processes.
processes. See here, have you ever noticed, look at this very carefully. Okay, look at very carefully. Have you ever noticed this one? So in this, if you see, this is a one application This is another application, one more, and each applications we have attached to one PID. See, unique PID. It's not duplicated also. And this PID now is running. That's the reason PID get allocated. See, if these applications are running PID, you get it. You won't get a PID for the non-running applications. Now, if you carefully look at it, this PID ID which is we have, so one is a PID. Okay, one is a PID. But if I want to say everything, this is come from PID tree. I mean, just conceptual keyword to understand in each way. Okay, PID tree. Okay, so PID tree, which like it will start with 0, then 1, then 2, then 3, then 4, then 5. How? So this you have a 0 means then 1. This 1 will run your kernel. Then 2 you probably logged in. This is Rajesh, and Rajesh run the Apache. So this is the PID tree. This is kind of tree will be created. Okay, so now you see that in a Linux, in Windows also, see everything got started with a 0, then 4, then 8, and then keep doing it. Now let me show in the Linux also. 3. Oh, what I did. See, if you see that everything start with a 0, then 1, then 2, and followed by all this thing. Look at it very carefully. This is the applications, this is the applications, this is the applications, and each applications you have one process ID attached to it. So question is, what is a PID tree? And question was, what is a PID tree? So PID tree is basically a tree of starting with a 0. So how many PID tree you can create? N number of. You instantiate, you get created. What is MNT? MNT means RFS. What is RFS? Can you please tell me RFS means? What is RFS? What is RFS? Hello? Just now I talked about it.
Storage and mounting the disks.
RFS means mount is equal to RFS is equal to root file system. Okay, root file system. So here when I say mount means root file system. What is the root file system? Just now I showed you here. I hope you remember. Where is that? Here it is. Everything start with the root file system. In Windows you have a my computer, right? That's a root file system. Inside that you have a C drive, E drive, all this thing. So how many C drive? I'll put it in this way. How many C drive you can create? N number of it. So here you see that. Remember that what we are focusing. What are the resources? Resources we are discussing. For what? We need to run what? One app. Let me look at this here. Look at this table, very simple way, easy way. This is your task manager. Okay. I'll snip it one more time. Very carefully look at this. And if I see that this is application SMSXEXE. Okay, let's target these applications. So if it is running, see the state is running. In order to run, what you need? The first thing you need PID. Focus. You need PID. What you need? Then in order to run any application, you need one user. You see that? The user here, it's a system. Here is Rajesh user is running this application. Go to meeting, I am running it. See that? But this is a system application. System user is running it. And every users, you have a certain CPU and certain RAM. So this is certain CPU and certain RAM and user. Now this file will be stored somewhere in the C program files. So you need a root file system for storing that program. So what do you need? Think about it. You need user. Here it is. You need pit tree. Here it is. And you need a mount root file system. This file is stored somewhere. Let me show you where it's stored. Or let's say go to meeting, where is stored. Here it is stored. So this C drive, then users. So this is a root file system, right? Likewise, if you see that in Linux, this application is running. It's stored somewhere. You have a users PID also. Are you understanding now this table? So that means if you try to find out what are the resources we need to run one applications, so you need a first kernel. First you need a hardware, okay, which we discuss. Okay, and then hardware you install the operating system which has a kernel. Kernel is nothing but a computer program. Computer kernel, we have a different types of program. One program is user namespace, net namespace, pid tree namespace, mnt namespace. What these namespace are doing? So user namespace will create a user. How many you create? Multiple. Can create multiple. Network namespace will create a network. Why? Because this application, if you look at this table here, these some of the application do not require network to run, but some application, let's say, do you have Apache running? Let me see that. See, Apache rewrite. Apache is required the network, right? Correct now? Because that way you access over the IP address and port number. Agree with me? All of you?
Yes, sir.
Yeah. So this is something which you need it. Now, next table is you understood that, okay. So kernel can have a mount namespace. It can create multiple C drive, multiple pit tree, multiple network, multiple user, but allowed. How many allowed in operating system? So tell me, how many users you can create in your laptop, in your operating system? Tell me. Simple question. How many?
Yes,
Mhm. Tell me.
multiple users,
Yes, multiple user allowed in operating system. By default, when you set up your operating system, how many network you get it? One. How many pit tree you have? Pit tree. Look at this pit tree. Starting with the pit tree 0, then 1, 2. So this is the pit tree. You see pit tree. Linux, Windows also you see PID. So 1. And how many C drive you have seen in your operating system? I'm putting in a very simple C. Or how many OPT you have seen it?
one OPT,
Yes. See that. So here, if you see that in your PC concept, you have only one network, one pit tree, one mount. One mount means one C drive or OPT. And users is allowed multiple. So how many can? So kernel can create how many? Kernel can create n number of it. But when you start the PC, it's not allowed more than one in this three scenario. Why? So the reason is PC concept. PC stand for PC stand for personal computing. So now when the computer was designed, they started thinking about what we will do with the multiple pit tree, multiple mount, multiple C drive, multiple network. Nothing. Okay, because we designed the system for the human being, personal computing, not for the data center. But multiple user they allowed. Why? Because you can log in, your brothers can log in, your teammates can log in, power user can log in, normal user can log in. All this thing is allowed. So here, now come back to the question, what are the resources we need to run one application? So here, need. So here you need only one user to run your application. network, bit tree, and mount. Only one you need to run your applications. Okay. So here, if you see that this table again, this table, see that I want to run go to meeting. So for that you need a one PID tree. So PID you got it. Now it's running. This is run by Rajesh Kumar user, and then you have a CPU and RAM here from this place. Got it? And then this file has to be stored in the root file system. So we need a root file system, and then root file system means C program files or something, or OPT something, or bar something in Linux, and then this will get stored. So you need a file system to store, then you need a RAM, a CPU, user, and network. Not required because it's not application, web application. So it's like that. So now, did you get an answer for this? What are the resources we need to run one applications, all of you? Did you get an understanding?
Yes, sir.
Yeah.
Yeah. Okay. Okay. So this is something which we have. So now let's recap this stuff, what we are coming here. So the first question why we came here, we came here to understand learning Docker. Okay. You came here to understand and learn Docker. So we learn what is Docker. So Docker is a container management platform. So platform means it will save cost, save time, improve quality. How it will save cost? So compare with the VMs. So VMs, if you run applications, let's say assumptions, 1 CPU, 1 GB RAM is required. But when you run containers, your applications, it required 1/5 of your infrastructure resources of the VM. That means saving cost. That means I can run in a lesser CPU, lesser RAM, I can run more container. How? We need to discuss. So that is the one reason for it. Again, VMs will take 5 minutes to create, but container 1 second. That means in 1 second you can create a whole infrastructure of dev, QA, and production. You want to run thousands of application, how much time it required? 1 second. And here we are saving time, saving cost. So of course you should focus on the code quality and test quality. And that is why people, every organization wants to migrate to Docker because of this anyway. What is a management means? Management means you are creating container using Docker. Using Docker. Docker is a container management. So management means create, start, stop, restart, pause, unpause, kill, and remove. So these are the things you do with the Docker. Docker, you can do these are the things. Something similar you were doing using VirtualBox. You were creating a VM, starting, stopping, restarting, pausing, unpausing. Now, then most important question is what is container then? So containers, in order to understand container, you need to understand what are the resources we need to run applications. So what are the resources we need? We need a hardware first. To run any applications, you need a hardware. If I say run Apache, then you will say give me laptop or VMs. Okay, so like that. So you have a hardware, then hardware will have a kernel. Okay, OS has a kernel plus root file system, two things. Remember that. So you have a kernel, and kernel is nothing but a computer program, and there are different types of computer program. So user namespace program is creating a user, multiple user. Network namespace will create a network, multiple network. Pit tree will create a multiple pit tree. MNT can create multiple pit tree. But how many allowed in the PC? 111, and users are multiple. But for running applications, how many need? One user, one network, one pit tree, one MNT. Now what C groups is doing? So C groups is allocating CPU and RAM CPU and RAM to PID. Okay, look at this here. Very carefully, if you see that, look at this, and carefully you see that. See here. Let me snip it. Now see that here, this all PID is getting allocated. So CPU will be only one at a time. Okay, this is called context switching. So all other CPU, sorry, all other applications are running. If you see that it's running, but not required CPU because you are not accessing it. So those who are accessing it, those only will get a CPU. So right now, GoToMeeting, I'm accessing it. So GoToMeeting has a CPU, and this is your system. Okay. So system also has a CPU. RAM, you'll get it to all running resources. So here in this picture, you will understand one thing. See, all the processes are running, all applications are running, which will consume RAM, but not CPU. CPU only if you are those applications which you are using at a time, you will be having CPU allocations. Okay. So the question was, what is C groups? C groups is a kind of code which is inside a kernel, which will allocate CPU and RAM to the process ID. Now, what is a capability is doing? So capability will see, there is one user which is called Ubuntu. There is one other user which is called root. So C group, sorry. So C groups will decide what is the root can do and what is the Ubuntu can do that. What is their privileges? So capabilities means their access, they will decide their access and all. Okay, so now did you understand that, guys? What are the resources we need to run any applications? All of you? Any questions, any confusion? Feel free to ask me. Any questions, any confusion?
No, sir.
Okay,
No, sir.
okay. So now the question was, what is container then? That is the real question. Because we understand when we are discussing about what is Docker, so we understand platform, what is management, what is container then? So now let's discuss about the container. So let's create some image. So now think about it. First, I will show you the physical server model. Okay, physical server model. So here you have a hardware, and then here you have a operating system. I'll just write it. Think about it. This is a hardware, and then you have operating system which has a kernel. Okay, and when I say kernel, always remember this library is actually. Okay, so kernel will create what? One network allowed. So let's create one network. Let me change the color of it. So this is the one network, and then what it will create? Then you'll create one bit tree. See here, bit tree, and then one mount, one C drive you can call it, or one OPT, root file system we call it here. So now you see that here. This is the okay. Okay, so okay, so now are you okay with this so far? This is your laptop hardware on top of operating system, and on top of that you have a network, bit tree, and root file system, MNT. Okay, how many users? So this is Rajesh, this is Rakesh, this is Kabya. So three users are there. Rajesh, let's say Karan, and let's call it Patrick. P, different names. Okay, RKP. Rajesh, what is that name? I forgot. Kabya and Patrick. So now tell me one thing. These guys, three guys logged into that laptop or that virtual machines. So they will see the same C drive, right? Correct, no? Same C drive
Right.
and same PID table also and same network. Why? Because you know these resources are common and shared by these three users. So see here, one user, two user, three user, they are sharing the resources. Agree with me?
Yeah, sir. Right.
Exactly.
Yes.
Okay, so now next thing is, let's understand this way. Now Rajesh want to run Apache. Okay, he logged into that machine, VMs, virtual machines, or laptop in a simple way. He logged into the VM and then he said, I want to run Apache. And Kavya also said, hey, I want to run Apache. And this guy, who's that? Patrick also said, hey, I want to run Apache. So now Apache, you will store somewhere in the C Apache. Okay, I'm putting in a very simple way. And then Apache, you are running with the 80 port. And the PID, when you run Apache, let's say PID will become 50. Okay, so PID, remember that again, look at this table here. PID, user, application, and all stuff like that. So port number 80, C Apache, and this one, 50 PID. Now tell me, Kavya will be able to run on 80 port? Yes or no?
I think no.
No. Why? Because port has been used. Correct now?
Yes.
So this guy, Patrick also will not be able to run on 80 port because port has been used. Now, Rajesh has stored the files in a C Apache. Now, Kavya cannot be storing that C Apache because integrity will be compromised. Correct? C Apache cannot
Yes.
use, she can use a C Apache 2 or C Apache 3 like this. So here the problem is, see here, the problem is, think about it. This was a physical servers. The problem is, here the problem is, in the one compute unit, you have this operating system and then environment. You cannot run three Apache. You cannot run three Apache over the 80 port number. You cannot run three Apache where you store the Apache in C Apache, all three Apache in C Apache. You cannot have the PID C Apache, Apache PID 50 for all this. If you, even if you change the port number and directory, it will run 50 PID 51 52. You see that here? None of those PIDs are duplicated. So this is the problem. That means in a simple way, in one machine, you cannot run three Apache. Agree with me, all of you?
Yes, I agree.
So now the question is, what is required? I want to run thousands of Apache. I want to run thousands of Apache. How come? Let me help you to visualize it. So this is giving you the complete picture here. This is the end user. They hit the domain x.com, which is a Twitter or devopschool.com, and then DNS will take to the load balancer, and load balancers will load balance at multiple Apache, one Apache, two Apache, three Apache, four Apache, 50 Apache. So now this all machines will be all our Apache will be load balanced by this load balancer. So traffic will be received from here to DNS, DNS to load balancer to this machines, and this machine to again load balancer of web server. So let's say this is Apache here, and here you have an app server. Okay, this is web server by the way, and this app server may be Tomcat. Okay, Tomcat 1, Tomcat 2, Tomcat 3, Tomcat 4, Tomcat 5 Java based applications. So here load balancer again, this load balancer is for the Tomcat. Okay, so traffic will be made from here to here, this machine, and then again to the load balancer, one more load balancer. And then this is your database. When you run the large set of infrastructure in the production, you see that here. You have, understand that, you have multiple Apache at the web layer. You have a multiple Tomcat of the app layer. You have a multiple MySQL database for the DB layer, and one load balancer for app, one load balancer for web, one load balancer for database. So three load balancer. And how the traffic is coming? You hit the DNS hit the web front of the load balancer transfer that to one of the machine to the load balancer of the app. Again, app or load balancer will transfer the traffic to the this one, and from here to database load balancer to this one, and that is how the whole traffic is coming. So the idea is you want to run thousands of Apache, thousands of Tomcat, hundreds of MySQL. Can you do that? No. Are you understanding, all of you?
Yes, I understand.
Okay. So now next question is, what is the solution? Then people say, hey, don't worry about that. Let's go for virtualization, virtual machines. Let's create a virtual machines. So what we did, understand that we had a hardware. Okay. Then we had a hypervisor category. Hypervisor means VMware kind of things, or Hyper-V, or VirtualBox, or AWS, or I mean hell lot of hypervisor. Just type the hypervisor. Look at this. Hypervisors and list of hypervisor. See that Google is giving you all this hypervisor. We are using VirtualBox for the desktop, but hell lot of solutions are there. AWS are also using some of the hypervisor. Google Cloud also using hypervisor. Depends on their use cases. Okay. So you have a hardware on top of hypervisor. Hypervisor, let's say HY, and this is hardware. And then what we are doing, we are creating, hypervisor is creating VMs. Okay, so this is a VM. One VM I'm creating, two VM I'm creating. Understand? Two VM I'm creating, three VM I'm creating. So now we have a three VMs actually. Okay, so you had a physical server, you cannot run multiple Apache. So now which we have a VM. I repeat, in the VM also you have operating system, don't you?
Yes, Moses.
In each VM you have operating system. And now when you have operating system, then you have a kernel, kernel. This is the VM, this is a VM, this is a VM, and then kernel. And I repeat, kernel again you have what? Same thing, one network, one pit tree, one mount, and one user. One network, one mount, one pit tree, one pit tree and one network. One network, one mount, one pit tree, one user. So now tell me, these are the VM environments. Now tell me, are we having Apache? Can I run Apache? This user can run Apache. This user can run Apache. This user can run Apache. Yes, this user is using Apache and 50 PID, 80 port C Apache. So mind it, this is using this mount, this network, this pit tray. Same, this guy also can run 80 port, 50 PID, C Apache. C Apache, 80 port, 50 PID. So now in this scenario, one machine, three users cannot run three Apache because of they are using same resources. But here what we did, you virtualize the resources. We had a new operating system, I mean different operating system, and resources are same, and now you are able to run three Apache. Agree with me or not? So why we migrated to VM? Now you understood this, all of you?
Yes, sir.
Now the question is, guys, VM technology is there from last 20 years. See, we are running the VMs in laptop. AWS is running the VM in data centers. Azure is running the VM in data centers. We all are using VM technology from last 20 years. Now tell me, VM is becoming costly actually, costly affair. Now become an architect, okay? That's very important. And tell me, you want to run three Apache, okay? Think simple, three Apache. That is your goal. Here I told you how many Apache I want to run in the production server. Thousands of Apache. Thousands of Apache I want to run, thousands of Tomcat I want to run, thousands of MySQL I want to run to create a web layer, app layer, and database layer in the production. So now when I look at the production cost, running cost is very high actually. So tell me, become an architect now. Tell me what is the drawbacks for this VM technology, because this technology we are using from 20 plus years, I guess. Tell me what is the drawbacks. Think about it. See,
Multiple resources we are having, multiple images, maybe
so if I
performance.
yeah, so if I look at the architecture here, think about it, because my goal is to run 3 Apache. Okay, so that means why 3 Apache? Because I want each Apache to be isolated. I repeat, isolation. So that's the reason I cannot run in this one machines. I have to create a 3 VMs for it. Because why we need a VM? For isolation. Different operating system, different port, different file system, different PID number, and all kind of things. We need isolations. Okay. So now this is becoming costly affairs day by day. Why? Because the size of the data center is growing. Earlier we were running 1,000 boxes. Now 10,000 boxes. So slowly the running infrastructure cost is growing. Also management is becoming very difficult. So is there any way I can do that? So here if I see the drawbacks in the virtual machines, if you see that I want to run 3 Apache, and for that I want to run 4 operating system. Agree with me? See here, there is one operating system here in hypervisor, here also, and there is one operating system here also. Correct? Agree with me? So in order to run 3 Apache, you need a 4 operating system here. Here you had only one operating system. 4 operating. That means 4OS means also it will consume CPU. Operating system also consumes CPU, RAM, and storage and licensing cost. And if I see that hypervisor also consuming lots of CPU, hypervisor also consuming lots of CPU, RAM, storage, and licensing cost. So because of this model, VM model is good, but nowadays it's becoming costly affair. Why? Because in order to run lots of resources is being wastage here. In this VM model, wastage of resources is happening. Are you understanding, all of you?
Yes, sir.
Yes,
So
sir.
now what to do now? So guys, now time has come for concluding the containers. So what is container? So what we are saying, hey, understand in simple way. What we are saying, not me, sorry. Um, who's the father of Docker? I forgot his name suddenly. Docker CEO. None of this. I forgot his name. Hmm. This guy. Solomon Hikes. This guy. This guy is a scientist, computer scientist, who who developed the Docker and their architecture. This guy is saying, and Docker is free, by the way. Everything is free in this world except your SARS. Okay. So here this guy developed this tool, and this guy said, hey, let's do one thing. We want to reduce the data center cost. Virtual machine is very heavy. For running application, you need a VMs, and VM also consumes CPU, RAM, and storage, and licensing cost, and so on. So let's create an architecture like this. I want you to look at this table very carefully. Here allowed it was only one bit tree by the kernel, but you can create n number of it theoretically. I hope you remember this discussion. So what he suggested, Solomon Hayek said, let's do one thing. Let's have a kernel. Now kernel you can have in the VMs and physical servers also. Okay, that is a things. Let's have a kernel, okay, based on the physical machines or hardware or virtual machines. So let's have this is the kernel which is operating system. And kernel, remember that kernel can create multiple user, multiple network, multiple bit tree, multiple mount. Understand this. So kernel, and then top of that one utility I will write it, one lightweight utility, and this is called Docker. Okay, understand that. So this utility is called Docker, and uh, here Docker will, and kernel you have all this namespace. Again I'm showing you all this namespace. Okay, so Docker will ask kernel, hey kernel, can you create one one network? Yes. Hey kernel, can you create one MNT? Yes. Hey kernel, can you create one network MNT in Pittree? Yes. Hey kernel, can you create one user? Yes. Hey kernel, can you create one more network? Yes. MNT, Petri, network, MNT, Petri, network, and user, and user. So now see here, kernel, you know that we discuss, right? Kernel can create multiple user, n user, multiple network, multiple Petri, multiple MNT, but it's allowed by PC. PC means personal computing world is allowed, but actually kernel is capable of doing multiple. Are you agreeing with me? All of you?
Yes, I agree.
So now Docker is saying, requesting kernel, hey kernel, can you do one thing? This user which you created, see, think about it. Here there is a user. This is also user, Rajesh, Karan, and Patrick. So all these three users are attached to the same resources here, same C drive, same pit tree, same network. But you know what? This user is attached to this network, this pit tree, this mount, this root file system. So here you see the difference. That means when you log into this user, you will have your own C drive. You log into this user, you have your own C drive. Then you log into this. I'm just giving you C drive example because you understand easy way. It can be OPT. Linux, it's OPT. So on OPT, here on OPT, here you want to run Apache. You are running 80 port, 80 port, 80 port. You want to 50 PID, 50 PID, 50 PID, C Apache or OPT Apache, OPT Apache, OPT Apache. So now tell me, this is powered by this one environment, powered by the kernel itself. So if I want to run three kind of Apache, how many kernel you need it here? Tell me. How many kernels you need it here?
What?
Only one, right? Only one. Uh, See here, there is a kernel here, kernel here, kernel here. There's no kernel here. So this all kernel isolation is created by kernel, but with the help of Docker. Are you understanding, all of you?
Yes, yes,
So now the question is, what is container? Anyone got this? What is a container? So guys, container is this is one container. This is another container. This is another container. Container, do we have operating system or tell me? Do you have operating system? No. So here container is your nothing but one network, one MNT, one pit tree, one user attached to each other, and that is called container. Now whose in managing the container managed by done by Docker, but who's creating a container, all this thing environment is done by kernel. And kernel you can have in the physical server or you can have in the virtual server. So now what is a container? Did you understand this? So what is the beauty here? So I want to run three Apache. I want only one kernel. Here in the VM model, I wanted to run three Apache. I was required four kernel, 1, 2, 3, and 4. And hypervisor is a very heavy also. Here there is no hypervisor. Docker is very lightweight, which you can use it. So guys, what is container? So container is a technical keyword. If I say container is a lightweight application running environment. Sorry, this is a functional definition. Okay. If you say technical definitions, then container is one PID, one user namespace, one network, and one forget MNT mount root file system. And by, so here one PID namespace, one PID user namespace, network namespace, and mount namespace requested by Docker, created by kernel. Understood all of you now? All of you?
Yes, Raj.
Yeah. So this is kernel. So what we discussed, what is Docker? So Docker is a container management platform. Guys, this have a multiple releases. One is community release, one is enterprise release. Community release is free. Enterprise release also is become free actually. Now earlier it was a paid, so I will say paid now, but support is paid, software is not paid, mind it. Software is free. Docker is written in Golang, okay, written in Golang, okay, and by Solomon Hykes. He's the father of Docker, by Solomon Hykes. And yeah, so written in Go by Solomon Hykes. It has a multiple release version. I think 20 version. I think 20.x or something. 22 maybe. I have to check it. So now, did you understand what is a Docker and what is container? All of you, any questions? Okay, so now what we understood, what is Docker and why do we need it and how Docker works. Now, next topic is I need to install the Docker and create a containers and stuff like that. Okay, so these are the four things I have to do. I have to install the Docker, component of Docker, life cycle of Docker container, working and accessing a containers and troubleshooting. So these four questions will take a one break for 10 to 15 minutes. And once we come back from the break, then we'll talk about it. Okay. Okay, so let's have a 10-15 minutes of break and then we'll connect it. 15 minutes of break.